Okay. This over. Okay. All right. So this is a little bit convoluted. So number one, there's supposed to be 5 of you. You have to do, so we'll figure that out. So I'm just working at this is physics. Hopefully that's what your schedule says. It's not psychic, like you don't get like your own like 800 number where you can predict the future and people call them, which would be cool. So this is going to be, well, this year is just going to be all jacked up for any number of reasons. So let's start with the obvious. So Kanani is, I've got, so let me explain how diverse my teaching load is going to be. So I've got the 2 honors physics classes. So I'll have like half of you today, and then another half on any given day. And then I've got 5 kids that are just completely learning at home. And so that's what Kanani just joined in on Zoom. So I've got that going. And so I've got like 3 different groups of kids to try and keep track of who's where and who's what and everything going on. And I'm a technological dinosaur, so the fact that I kind of got this thing to work right now with the Zoom meeting is kind of impressive. Thank you very much. Just do better from Superintendent. Okay, so here's what's going to happen today. So I got to go through a whole bunch of stuff like how I'm going to expect homework to be handed in, the expectations of the class, kind of the general first day stuff. So I've got, normally I don't hand out any paperwork at all the first day. If this was a normal class year, I wouldn't hand out any paperwork at all. But because there's so much that's changed and expectations and things like that, we got a bunch of paperwork to go through. But here's, can you all hear me talking to the mask? Okay. Well, yeah, no idea what is going on. So there's pros and cons of how this deal is going to play out. So initially, what's going to happen? I will see you guys again on Thursday. So, and I'm usually not that organized, but I'm forced to get organized because I've got so many items in the file. So what will typically happen once we get kind of past these first 2 days. So like on Thursday, you all are going to be back in here. And I will always record one of my lectures in the first or third block that I will dump out on YouTube. So even if you're gone, or even if you're here and you want to go back and like watch a lecture again, that's going to be an option. So if, let's say, even if you guys are supposed to be here, but you're homesick and when in doubt, stay home, okay? Literally, when in doubt, stay home. Love y'all to death, okay? And I wish I was, you know, young and invincible and things like that, but I'm 54. And unfortunately, being 54 years old, if I get it, it's probably not going to end as well as if you all get it because you all were young and healthy and all that good jazz. Hence the mask. And well, I've got a fan going back there with a filter on it. It's going to filter out some of the droplets. So when you get in, there is that hand pump over there. So when you come in, pump that, boom, here you go. So y'all are socially distanced. I like that. And I've got to speak through a mask, which is going to kill me by the end of the day. So with all that said, it's cool to be teaching again. I did the math. It's been like 6 months since I've actually like interacted with kids as opposed to just like teaching to a camera, and it's a good feeling. Yes, and you all are kind of like, wow, we're back in the classroom. It's kind of a cool deal. So there's going to be some pros and cons to this learning process. You know, like I said, because of technology and because of the fact that this is a college level class, you're going to be, I've got to basically cover material at the same pace. It's horrible. At the same pace as I would if this was like a normal school year. So it isn't like I can teach you guys this lesson and then teach that same lesson the next day. Otherwise, I'd only be able to cover half the material. So we're going to do that at the beginning, where just for these first 2 days. So once we really get cranked up and going, then, like say on Thursday when you all are back in here. So what I'm going to try and do on the days that you all are here, that's when I'm trying to give you the experience to do the hands-on labs, okay, to collect the data, you know, because that's kind of the cool part about physics, is being able to do the hands-on aspect of it. So for those of you that are at home, you're just doing the remote side of this, I'm just going to basically, you're going to watch you guys collect the data and do the lab, and then they'll just crunch the numbers based upon the data that you guys give them. So that's how that will play out. So that's what I'm trying to do on the days that you guys are here, is try and give you as much as of a hands-on experience as I can with that. So let's talk about a couple of policies. This is somewhat relevant to even of you that are watching on the Zoom. So one of the things that in this age of technology is this issue of cell phone use, okay? So you'll notice that my cell phone is up there in that packet. It's up there in number 1, okay? So here's the deal. So we're going to have enough distractions this year trying to learn and trying to teach and everything else. So I'm going to give you all a contract, and it basically says, hey, when you all walk in the store, your cell phone goes up there. Now, there's only like at most 5 of you in this particular section, so it isn't like I'm not going to know, oh, I kept my cell phone. Now, here's the reason I do that, okay? I started teaching 30 years ago. I've been in teaching in this room alone, since 1996, okay? The tables, especially the ones with the red on it, those tables were bought in 1994. Okay, so these tables are older than you all are, okay, by a long shot. And I've been teaching for quite a while. And so the reason that I adopt that cell phone policy, and myself included, okay, that's why I have my cell phone up here, because I don't want to be distracted. I want to be in the moment of teaching with you guys. But, and for those of you that are, you know, watching on Zoom or whatever, okay, trying to minimize the distraction. And here's the reason why, is because in 30 years of teaching, and this is going to sound odd, but I've never taught anyone anything, okay, in my 30 years of teaching. Never have. And no one has ever taught you anything. What has happened, and you're all sitting going, whoa, 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 30 years and doing this and you haven't taught anyone anything. I haven't. Because learning is an active process, okay? You have to make that decision, say, hey, I'm going to embrace this new bit of information, this new bit of knowledge, okay? It isn't like I can just sit up here and talk and then magically it absorbs into the brain. It's an active process. And so what I've got to do is basically get you to buy what I'm selling. It's like, okay, so what is this, topic? What's going to happen? How do I get you motivated enough to decide, hey, I'm going to take this information and I'm going to fit that into an existing neural network that already exists in the brain. Physics is basically a math class that we have cool things like helicopters and roller coasters and beds of nails and things like that. Okay? That's it. Physics is just basically math, but it's cool math. Because when I was going through K-State, that's actually what I studied most, was mathematics. But then I figured out early on that teaching math was kind of boring. Okay, like it really was. It's like, okay, what can you do as a math class? Oh, today class, we're going to learn the quadratic formula. Okay, well, that's cool. All right. In physics class, we take that same quadratic and we apply it to the orbital path of a lunar mission to the moon. And okay, when do you cross the Lagrange point, which is this point where the forces are balanced out. And so you use math, but it really makes sense in how you use it. So physics is just basically a really, really hands-on mathematics. That's all it is. So if you imagine learning as being like a wave, okay? So here's the challenge that I face as your teacher, okay? So if I put this wave and I put this information too far out in front of you, then you all will just get lost, and it's just going to be a train wreck. So if I start in on the very first day and say, okay, class, hey, we're going to talk about, we're going to do physics, and we're going to use calculus to do it, and we're going to talk about integrals and derivatives. And if you haven't had calculus, well, then that information is going to be so far out in front of you that you're just going to go, well, what's the point? I can't do calculus, so I don't know what you're doing, and I can't solve problems, and you all just get frustrated. The other side of it is, though, I can't make it too easy, okay? Because if I put this information well behind this wave, then you all are going to get bored out of your mind. So, you know, hanging up on this big sign in the back of the room that says F equals ma, force equals mass times acceleration, okay? And that's like the mother of all physics equations, Einstein's second law of motion. And I could make physics class the easiest class in Mays High School, okay? I really could. We could do 18 weeks of solving a F equals ma problem, and you all would get bored out of your minds. And I would be doing it to service because I wouldn't challenge you intellectually. So I can't make it too difficult and put you out in front of the curve or out in front of the wave too far. But I can't work behind the wave too far, or y'all are going to get bored. So what I've got to do is find a way to just kind of keep this information just out in front of the wave. In other words, just enough to keep you challenged, but not so far out in front that you give up. And I can't make it too easy, or it's like, oh, geez, you know, you got busy work to do. And so that's why I'm going to run this class like I'm going to in terms of keeping you challenged. Now, it's going to require a little bit of work on your part. So what you all are going to have to do on your off days, okay, not tomorrow, okay, but like on Friday, the decision that you're going to have to make is, and you've got options, okay? So like on Friday, during third block, you can do what Connie just did. You should all have gotten like an invitation to join the Zoom meeting. So on Friday, when I'm teaching, you guys are the red group. So on Friday, when I'm teaching the white group, then you guys have a couple of options. You can Zoom in, okay, and I'll let you in, and you can watch it just like Connie is doing right now, okay, and you're going to get this interaction. That's really handy, like if you have a question, okay. So it's like, hey, you know, you've got an assignment, and so typically here's how I structure my class. So like on Thursday, you all are going to do, you all are going to collect data for Spring Lab, and that's going to be due on Monday. So on Monday, I'm going to say, hey, do you all have any questions about the assignment? And if you're watching with the Zoom, you can type in the chat and go, hey, this is working, can you talk about number, whatever. So what that means is that, well, hopefully the other two show up eventually. I need one of you to sit up here and monitor, not today, okay, we don't have to do it by day, but I need one of you, if you would, that would sit up here in the front row and then basically monitor the chat on the Zoom. So that way, if somebody's, and I'm going to have somebody do that for you guys when you guys are at home as well. So if you want to watch like the live interaction, going over questions, things like that, you can do that. I'll also record that lecture, like I'm doing with this, and dump that out on YouTube. And so you can watch that later on in the day. So on any given day, I don't care how you get this lecture information. You can either Zoom in and watch it live, or you can wait until the end of the day when I dump that lecture out on YouTube, and you can watch it then. So personal preference. It doesn't make any difference to me, but this is going to be, that responsibility is going to be on you. So it's whatever works for you. And the advantage of dumping that out on YouTube is that even if when you want to go back and study for the first test, you go, okay, wow, we're going to be talking about independent, dependent variables. I don't remember what that is. I can go back and watch that lecture and use that to prepare for the test. Okay? So that's going to be a key thing. Now, the other thing that's going to be important is just a communication point. So I have an idea how this process is going to work from this side of the camera, okay? But as we go through this, like, if the camera's out of focus, or you can't read what I'm writing on the board, or any number of things, you have to communicate with me, because if I don't hear anything, I'm going to think, hey, this process is going okay, right? We're on a roll here. So that's what I'm going to assume. But literally, like, when I ask questions, like, for example, on this first lab, I'm going to say, hey, does anybody have any questions over the lab? And if no one says anything, I'm going to assume that you all understand it and have no questions at all. But here's how you have to view this from my perspective. And this is going to sound egotistical, and I'll admit it from the beginning. But fundamentally, your job is to keep me happy, okay? And I realize that sounds egotistical. Wow, but it's true though, okay? So if I'm happy, right, I have papers that are very well written, they're organized, they're legible, and the answers are right. You're going to get good grades. If I get a paper where things have been marked out, okay, and scribbled out, and the answers are wrong, and I get frustrated, you're not going to get a good grade on that assignment, okay? So fundamentally, to a certain degree, your grade on any assignment or test or lab depends upon my happiness, okay? But any teacher, if you think about it, this is true of any teacher, that isn't just me, okay? That's the honest, that's true. So this is why, in terms of keeping me happy, and my classroom policies, generally I have 2 classroom rules. It's pretty simple. You learn what I teach you, and you don't irritate me in the process, okay? That's it, okay? Those are the 2 classroom rules. Keep that in mind, hey, we're going to be fine. So the next logical question is, what irritates you? Well, what irritates me is like papers that are written and you've used a pen. I hate writing in pens, okay? And I hate it because, shockingly, you are teenagers. You might make a mistake, and then if you wrote it in pen and you scribbled it all out, and then it just looks horrible, and then I get frustrated when I grade it, and that makes me happy. Because what's going to happen, and I'll go through this CAM standard app in just a second, is that you all, unless you happen to be here on test day, you all are going to take pictures of your assignments using the CAM standard app and send those to me. So, and then I'm going to grade it on my iPad, and then I'm going to send that back to you as a PDF file. So this is why it's so important that you write legibly, because when you take pictures of this stuff with that CAM scanner app, if sorry, if you haven't written legibly, then, and if stuff is marked out, then it just becomes more and more difficult for me to read it, and then I get frustrated and bad things happen. So we're going to have enough things to worry about in trying to teach and learn in a pandemic, okay? Whether or not I can read your paper, let's just eliminate that as a possibility of something that we're going to worry about. Notoriously, that's guys that have the damn bad handwriting on the side. So starting on Thursday, I'm going to need someone to sit here, monitor. Can you handle this? Okay, all right. We have our volunteer. So, yeah, okay. Yeah, so it's going to be pretty simple. Okay, so let's talk about physics. So when you look at physics in terms of, actually, while I'm on roll with the administrator, I'll save the cool stuff till later. I'm going to hand out all the paperwork right. So I'm going to be handing out papers. I'm not leaving you. So if you want to stand up, take a stretch, this is when I'm going to hand out papers. So I have questions to hand out. Okay, so that's why we're on the administrative role. So on the cell phone policy. So here's what I ask is that when you all walk in, the cell phones go off. Now here's the reason why. They did a study and they had people just walking through a park, okay? And they had 3 different groups of people. The first group, you could have your cell phones out, you could talk on it, you could look on the app, you could do whatever you wanted to do, full access to your cell phone, okay? The second group had their cell phones, but they had to have them on vibrate, and they had to have them in their pockets, okay? But they couldn't access their phones, but they just had them in their pockets. So that would be like you guys having them in your book bag or in your pocket. And the third group had absolutely no access to their cell phones at all. Like they had to leave them, couldn't even access them. So after these people took this walk in the park, they asked them a series of questions about what they observed. Okay, like, you know, was there a bench? You know, what color were the flowers? You know, were the trees in bloom? Things like this, just general observations. And oddly enough, which group do you think scored the highest in terms of making observations? Yeah, the ones that had no cell phones at all, because they were in the moment. They can make those observations and see what was going on. And what's odd is that even the people that had their phone in their pockets, when that went off, they were distracted because they thought, oh, who texted me? You know, oh, what's happening? You know, oh, who TikTok video came out? I hate TikTok videos, by the way. Abhor them. So that's why I had this policy. Because, and now here's the reality. You all have signed up for this class. You don't have to have this class to graduate. And I applaud you all for taking this class. And here's the reason why. Is that it used to be you could graduate from high school and you could go out and you could get like a pretty decent paying job. Okay? You could. Working at a factory, maybe Boeing, maybe Spirit, something like that. Okay? Well, here's the problem with computers and artificial intelligence, is that those jobs are disappearing. Okay? They are. That's the reality. So it's harder and harder and harder for you to go out into the workplace and get a decent paying job without a unique skill set. Now, here's the reality, is that probably when you do a job interview, the boss isn't going to, or the person doing the interview probably isn't going to go, hey, you know, I'm going to drop a steel ball from the top of the Empire State Building that's, you know, 500 feet tall. I want you to calculate the velocity of the ball at impact, okay? But I'm not going to ask you that question, unless you're like applying to be a physicist. But what is important is that, and what people will hire you to do, is to solve problems. Because if it's a menial task, more and more they're going to develop a robot that's going to be able to do that job. So what physics is going to get you, and I've heard this from so many of my kids that I've taught over these 30 years, is that what physics does is that it teaches you how to solve a problem. Okay? It teaches you how to think. And that's one of the most vital skills. So like Bailey Dobler, she graduated 4 or 5 years ago. She went down to Oklahoma State. And she said the beauty of this class, and Bailey is like a marketing major, okay? It doesn't have anything to do with physics. But she said the beauty of what this class did is that it prepared her for college, for the rigor of college, for being able to, you know, have a certain amount of homework that was due the next day. So that's why I applaud you all for taking this, because not only do you, when you go out in the workplace, not only do you have to compete for jobs with other graduates of Mace High School, you've got to compete with all the graduates from around this area. And more because of the internet, and now because of this pandemic and people working at home, you've got to compete with people in India, from China, from England, okay? It isn't like now you have to compete with just the people that are in your geographic location. Because of the internet, because of Zoom meetings and just like this, you have to compete on a much broader scale. And you basically need every advantage that you can get. And so that's why yeah, this class is going to be hard work, but you have to realize you're going to be competing against a group of people that you haven't even met yet that are on other continents. So you need every advantage that you can get to help you out. And like I said, you're not going to get a job solving physics problems. What you are going to get is the opportunity to think through complex problems, and that's an important skill that you have to have. Okay, so that's why I have that cell phone policy. I'm not doing it to be a jerk, and like I said, I'm going to do the same thing. My phone is up there because when I'm teaching, I'm going to be in the moment. And I'm not, because I can guarantee you, if I have my phone and I get a text message or something, I'm automatically, it's just human nature. You're going to think, wow, who texted me? It's just what's going to happen. Now, obviously, if you're on a Zoom meeting at home, hey, if you have your phone, I'll never know. I have 1,000 things to worry about. But at least when you're physically in the room, just put that up there. And this is the beauty of teaching the level of kids that I do. Like I was talking with a new teacher, and the teacher said, well, how do you write up a kid and send them to the office? Like she's asking, like, what's the procedure? I said, I honestly don't know. I honestly cannot tell you the last time I sent a kid to the office. It has not, I don't think it's been since I started teaching in this building in 1996, which was like 24 years ago. Okay? I said, I don't know. I said, I don't know what to do, what you do when you send your kid to the office, because I just don't worry about it, because I teach phenomenal kids that are, have signed up for this class. And this is why with the cell phone policy, it's just, it's an honor thing, okay? You all are taking the class, and because, and let's say that, well, I'm going to have my phone out. Well, here's why I don't allow that. And people make the arguments like, well, it's just impacting me. No, it's not, because I can guarantee you, even being socially distanced, if your phone goes off and you're looking at it, she's going to be distracted, and I'm going to be distracted. And that isn't fair to everyone else that's in the room. So that's why I have that policy. Okay. I know you all, it was funny in first block. So the kids were in here, I got like 7 kids in first block. And I looked up, now mind you, here are a group of kids that hadn't seen each other, or at least been in a classroom since the middle of March. And I just sat up here and I watched. They came in, none of them asked each other how they were doing, how you've been. There was absolutely no verbal communication whatsoever. They were all staring at their phones. Okay, literally, that was it. They were all staring at their phones. Like you all hadn't been in, you all just got off with the longest spring break in the history of education. And you all are in a room and y'all are staring at your phones. So that's pretty simple. Like, oh, come on, people. Let's have a little bit of human interaction, please. Just a little bit. Okay. So let me kind of go over the policy and how this is going to play out. So you have I've given you a calendar, okay, which I'm normally not that organized at all, but this is a rare feat of organizational skill. I even like color coordinated it as like you guys are in red. Kanani, I sent this in your packet that you're going to have. And so basically I lay out what is expected of you every day for these first 2 weeks. And so like I said, if you're here, it's not going to be a problem. It's on those odd days that you're remote learning. So, and I tried to lay out, hey, this is when these assignments are going to be due, that type of thing. So what you all are going to have to do is you're going to have to keep like a time log, and this is, the teachers haven't stressed this to you. This is going to be very, very important that you keep that time log. So what I've done starting on Thursday, it won't apply to you guys, but it'll be for Friday for you guys. Down at the bottom, and Kanani and you guys, remote learners, this is going to apply to you every day starting Thursday. So what I've done at the bottom, if you look at that, I said, okay, this is how long I think the lecture is going to take. and then this is how long I think the homework is going to take. So that way, when you fill out your log, you at least have somewhat of an idea. Now, don't flip out and go, hey, you know, Burkamp, you know, you've put down homework as 40 minutes, it took me 35. It's okay, call it 40. That's kind of an estimate. Now, some of you, it might take you longer than 40 minutes to do that assignment, okay? It might, okay, that's legitimate. And if you want to put down like a longer amount of time so that you end up, so you have like a cushion relative to your other classes that might not have as much time, hey, great. Because the magic number at the end of each day is that it adds up to 380 minutes. Don't worry about it today because you're all in class. But on those times, so that's what, on those days that you're remote learning, that's what I have down there at the bottom that says, okay, hey, this is kind of my estimate on what I think the lecture is going to do and how much time I think the homework is going to take. So that at least gives you some reference for filling in that time log for those 90 minutes. So in terms of assignments, almost every time I give you an assignment or a lab, it's going to be due the next day. Sometimes the labs will take a couple of days to get all the data. That doesn't happen very often, but it does happen. But generally, especially on homework, if I say, hey, here's the deal, like you're going to have like an assignment on dimensional analysis. Unless I explicitly tell you otherwise, that assignment is going to be due the next day. So here's how assignments can be handed in. So let me hopefully this works. Oh, yes, score. Okay. So what I've given you all is this packet on using Canvas. So if you haven't downloaded the app, it's an easy app. So this is this big packet of stuff that I printed out. And that took me a long time to do, okay? And I'm not that technologically savvy. I've got my pictures and arrows. So here's, this process is going to start. Get the Cam Scanner app downloaded. So, and you've got your assignment. And so let's say that this is your assignment, okay? So there's, and this is what I used in the spring when we shut everything down, and it worked well. So just lay the paper out. It works better if it's like on a darker border, like on a contrast, because what happens is that when it takes a picture of it, it crops it so you're just seeing the picture, or the paper itself. So a lot of times on your assignment, it's rare that something is just going to be like one page. Most of the time it's going to be like a multi-page document. So yeah, once you get it downloaded, you can choose whether it's single or if it's going to be more than one. You want to make sure that you pick the batch mode. Okay? Otherwise, you have to send individual single pictures, and it's a pain, and they'll do that. So that's why you want to go the batch mode. So when you take those pictures, and so this is what it's going to look like. So this is why it's important that you have this against the backdrop. Now, here's the other thing. Make sure that that thing's in focus, because if it's not and it's fuzzy, you have to view this from like my perspective, in that I'm going to have to grade like 30 honors physics assignments at a time. So and this goes back to keeping me happy. So if your picture is out of focus and I can't read it, that becomes very, very difficult for me to read. So if you take a picture and it's fuzzy, just redo it, okay? Just delete it, don't send it, because here's the process of what's going to happen. You're going to send me as a PDF file. And by the way, do not save this thing in Google Drive and send it from Google or Google Classroom or whatever. Google Classroom, files, whatever, and this program do not play nicely together, okay? I'm telling you, it turns into a train wreck, bad things happen, okay? So you can link it to your email, okay, and send it to me, but if you save it in Google and send it out of Google, it is horrible for me because I have to resave it and bad things are going to happen. Okay. Now, after you get it sent to me, and then if you want to save it to your Google Drive, that's fine. But don't try and send something to Google Drive because what I have to do is once I get it, then I upload it into this program called Notability, and that's what allows me to annotate on it. So Notability and Google don't like each other. Okay, that's bad. Okay, I can make it work, but it's a lot of extra steps for me. Oh, by the way, if I'm not, it's rare that I say, hey, this is a cool thing to get, but Notability, if you're an audio kind of learner, so the cool thing about Notability is if you have it on your iPad, that doesn't work with like Dell computers and things like that. But if I were you all and I was going into college, I'd look into downloading this app because here's the cool thing about it is that when you're in the app, you can tell it to record. So it would record this lecture, and then you're taking notes as you go. Okay. But then if you go, when you get done, and let's say, for example, you want to go back and listen to the portion on momentum. Okay. So if you go back into the program and you like highlight that word momentum, it will start playing that, at least the audio portion of the lecture from that point. So you can hear what I was talking about when I was talking about the word momentum. So that's kind of a cool thing. So like I said, you don't have to have it for this class. Don't go out and go, Mr. Brookhamp says we have to have Notability. I've got the program. But I'm just telling you that I was going into college. It's a really, really cool thing to have. If you really like to be able to take notes and listen back so you can get that, because some people learn differently. Some people write it down. Some people just listen. Some people do both. You have to figure out what your learning style is best for you. So what happens is that, and why this is relevant. So when I get an assignment, I'm going to upload it into Notability, and then that's how I'm going to grade it. So it has to be as a PDF file that you send it to me. I'm going to grade it. I'm going to send it back to you as a PDF file. And so that's why Google Drive doesn't work so well unless maybe they fix some things. I don't want to run that risk. Okay, so we're back here. So then when you get done, after them, you're going to hit this arrow, right? It's going to export the file. So this is the most critical step, okay? And again, you have to view this from my perspective in terms of how I'm going to keep track of this. So what you're going to have when you rename this, like, okay, Jared, what's going to happen is that the app is going to randomly assign it a number, okay? Here's the problem. When I go to grade it and save it, this does me no good at all, okay? This does me nothing because I have to save it as a file associated with the cherry, okay? This number does me no good. So when you do this, up here in this right-hand corner, there is a little box with an arrow pointer, or like a little pencil. So if you tap in that, that will allow you to generate your own title for the file. And I laid this out. So how I want it done is your last name and then the name of whatever that assignment is. So like the first thing I want you guys to do is that letter or that contract about the cell phones, okay? So here's your first assignment, is that I want you to sign that, assuming that you're going to stay in the class and abide by the rules. And then use Cam Scanner to take a picture of that and send that to me. And so Jared would put like Alan and like cell phone letter or whatever that is. On the assignments, I'm trying to be organized, and I will always tell you what I want the name of the assignment to be, right? And that'll typically be like in the top right-hand corner. So now, if you're at home and if mom and dad have a scanner, that actually works easier and better. In an ideal world, If you have a scanner at home, that's absolutely the best way to get that to me because it's easier. You just lay it on the top, it feeds through, take pictures of it, you send it to me, easy peasy. Don't go out and buy it. Do not. Go home and tell mom and pop, Mr. Burkamp says we have to go buy a $200 scanner. No, okay, don't. But if you have one, okay, if you happen to have a scanner at home, that's actually the easiest way to get that to me. Okay, but this is going to be the most important step, is that you rename this file. Now, when you get down towards the bottom, when you go to export it, okay, and on that email, and it takes a little bit to set it up because you've got to type in my email address. It's at the top of the syllabus that I gave you. It's just sburkamp@usd26.com. But also what's going to be important is that when you export it, you've got to save it as a PDF file. Because if I have it as a PDF file, then when I go to upload it into that Notability app, that's what allows me to write on it. So there's going to be two vital things that you have to do on each of these. Rename the file, and then save it as a PDF file. Those are going to be the two most critical things that have to happen. Because I love you all to death, but you're not ever, unless it's a test, you're not physically going to hand in any papers because I don't want, and I'm believing I am not a germaphobe overall, but you know, the thought of doing this just doesn't do much for me. So that's why it'll be all done electronically. I will send it back to you electronically. Life is going to be good. So that's going to be one of the most critical aspects. And then there's my email address. It's on there. It's also at the top of that. And so this is what it should look like. So this is what I said. Okay, hey, Burkamp electric field problem, whatever that is. And then that's how it's going to show up to me. Easy peasy. I upload it, I grade it, I send it back to you as a PDF file. So we're good with that. Okay, I know y'all have been sitting. Stand up, take a quick stretch, and then I need to do that too and get something good. So I'm going to pause this community for just a second. How are we doing, Kanani? Fantastic. Okay. Okay. Connie, we're back. All right. So let's talk about physics. So here is the cool thing about physics relative to all the other sciences, especially biology. So, and I realize biology is important, okay? It is. Hopefully biology comes through and they get the vaccine going and we can put it into all of this. But if you look at like the three big branches of science, biology, chemistry, and physics. So in terms of biology and chemistry, you all really don't have like an innate feel of the basic ideas of biology. So, okay, you all have biology, right? Anybody remember the role of the mitochondria in the cell? What'd you say? The powerhouse of the cell, which is brilliant for you guys because nobody in first block remembered that. It's like, okay, this is what everybody remembers out of biology. The mitochondria is the powerhouse of the cell. So it isn't like you can take like a slide and look underneath a microscope and go, oh, well, there's the nucleus of the cell. Oh, well, there's the mitochondria. Oh, there's the powerhouse. Oh, we have messenger RNA and and DNA. And no, okay, you do not have an innate understanding of biology. Chemistry is even worse. Okay, so it isn't like you all walked into Chem 1 on the very first day. Do y'all have Mrs. Shirts? Okay, yeah. Mrs. Shirts walks into my room and flips out because everything in her room is so organized and everything. And she walks into my room and she just starts to twitch because she really, really wants to clean and organize my room, and I want better than just kind of nuts. So But you do not walk into chemistry class and say, okay, class, let's talk about aluminum, okay? And you would go, oh yeah, aluminum, get it, right, it has 3 valence electrons. It's going to lose those 3 valence electrons and have 13 protons left over. It's going to form a charge of 3 plus. It's going to bond with chlorine, which has 7 valence electrons, and we're going to end up with aluminum chloride AlCl3. Okay? You all do not walk into a chemistry class with an innate understanding of the bonding nature of elements on the periodic table. Let's talk about physics. So if I hold up this magnet, okay, and I drop it, what's going to happen? It's going to fall, right? It's going to begin to accelerate, right? Oh, hello. Why? Gravity, right? Okay, right? How do we do it? Since probably you all were maybe 2 or 3 years old, you all have understood gravity, right? You have. So it's like, oh, I don't want, you take a 2 or 3-year-old, put them on top of the table. Little Timmy probably doesn't want to fall off the table, even though Timmy has no concept of gravitational fields, math, anything like that. Timmy's going to go, wow, that's probably going to hurt. So over here, okay, we're going to use this a lot. This is Hank, okay? Hank's bowling ball. Pretty massive, okay? And it says Hank right there. So Hank, class, this is Hank. We'll use Hank a lot. So you all, even though without having studied any physics at all, if I said, okay, you can have one of 2 things dropped on your hand. You can either have the magnet dropped on your hand, or you can have Hank dropped on your hand. It's like, oh, let's go with the magnet, thank you very much, okay? Even though you all have not studied force equals mass times acceleration, you've not studied Newton's formula laws, but you intuitively understand, it's like, wow, that thing's going to be really heavy. It's going to hurt, okay? You all intuitively understand that when you look at F equals ma, that force equals pain, okay? If it hits my hand, wow, that's going to be a lot of force. That's going to cause a lot of pain. You all understand that. So what physicists try to do is that we try and figure out a mathematical way to describe what is happening in the world around us. Okay, that's fundamentally what we do. So just like if you're an artist, you use different mediums. You might use paint, you might use sculpture, you might do clay, you might do wire, you might do photography. Okay? But you're trying to figure out what's happening in the world around you and use that to describe that idea. So that's what physicists try to do. We're just trying to figure out what's happening in the world, and we use math to describe that. So if we come up with a formula and we predict that, okay, if I drop Hank from a certain height, it should take Hank 5 seconds to fall. And we actually do the experiment, it takes about 5 seconds. Oh, okay, hey, that's a valid description. Now, if our formula says, oh, it should take Hank 20 seconds to fall, but it only takes 5 seconds, well, then that mathematical description doesn't work. So if you hate word problems, physics is not the class for you. Basically, every problem that you're going to do is going to be a word problem, but it's going to be relative. Okay, hey, I'm going to launch an F-16 Hornet off of the aircraft carrier. Here's the length of the aircraft carrier. What's the acceleration of the Super Hornet? How much force does it take to stop that plane when it lands? That's what physicists try to do. Now, the beauty of physics is that, unlike about every other branch of science, physicists deals with the extremes. So, in the course of teaching 30 years, I let kids go on and study and work at different places. So, this cup came from, it's broken. I gave it a new one. But this is from the Jet Propulsion Laboratory in Pasadena, California. So Michael Staub, one of my former students, worked for JPL. And if you remember, this is about 3 or 4 years ago, there was a probe that we sent to Saturn, like the Cassini probe, and it brought back a tremendous amount of information. If you ever get bored, just Google the Cassini mission. There's stunning photography and like the moons of Jupiter, the names that did so much for science. And so Michael was what was known as the mission ace. So he sat there and his job was to monitor the spacecraft. And so one of the things it did, like they crashed Cassini into Saturn because they were afraid it was going to get contaminated if it landed on one of the moons. And so, he was the one monitoring that Cassini spacecraft as it entered the atmosphere. So you have a branch of science that deals with the very large. Like, okay, hey, what's the mass of the sun? Okay, I don't know, pretty big, all right? What's the mass of the Milky Way galaxy? How far is the closest star? What's the fate of the universe? Is the universe just going to die out? What are we going to do? How long do we have? So you have a branch of physics that deals with very, very large objects, okay? So then you also have a branch of physics, and this is another one of my students, did an internship at Fermilab. And Fermilab is up at Chicago. It was the first big particle accelerator in the United States. So a couple of years ago, Reed Bowles was doing an internship up there in Chicago, and so I drove up there and saw him. And so what Fermilab does is Fermilab is trying to figure out what's the building blocks of the universe. Okay, we have protons, electrons, and neutrons. Okay, you all learned that in Chem 1. Okay, well, then the question is, well, what are protons made of? What are neutrons made of? What are electrons made of? And so you have that branch of science, which is the other extreme, and they're trying to figure out, okay, what's the basic building block of the universe? Right, that's the other side of it. So in physics, you have this extreme from what is the fundamental nature of the smallest building block that we can have, to the other side of physics, which is, hey, how big is the Milky Way galaxy? How fast are galaxies moving through space? So you have this extreme in magnitude of what you do. So what we're going to study is like page 1 of a 1,000-page physics novel. So I'm just going to try and get you the basics of how we do physics. So the very first unit that we're going to cover is called the Mathematical Toolkit. So before you can do physics, I have to give you basically a set of skills, because it's somewhat analogous to working on your car, okay? So if you know that the water pump is out on your car, it's great, okay? It's overheating, cars running right, the water pump is out. But if you don't have the tools to change out the water pump, that information doesn't do you any good. So the same thing is going to be true of physics. You all understand physics, okay? Gravity, force, all this good stuff. What I've got to give you is the tools to do physics, okay? Like how we do experiments, how we find variables, what units are we going to use, that type of thing. So that's the first thing that I have to do. So to kind of expedite this process and get through some stuff. So today after school, and this is going to be your other quote assignment, is that today after school, I'm going to record a lecture on what's called the MKS system, meters, kilograms, seconds. Typically, in a normal year, I would give that lecture, but in the name of time, because we're kind of starting making everything else, I'm going to post that out on YouTube, and I'm going to email you that link, okay? So, but I won't have a chance to do that until after school. So it won't take long. It's like a 30-minute lecture, but it basically lays out and says, okay, in physics, this is what we're going to use to measure things. So that's going to form the framework of all the measurements that we're going to do going forward on that MKS system. So you do have the lecture notes on it. You already have those, but there's going to be a lecture that I'm going to post out on YouTube, and I will email you all that link, okay, to send that out, and so that you will have that to watch. So if you look at kind of the cool aspect of physics, and this is one of the things that draws a lot of people to it. So I've got, this is a pretty strong magnet, okay? So, magnets are cool because you can do a bunch of stuff with them. But, and this is a piece of aluminum pipe, okay? There's nothing, okay? Just a hollow aluminum pipe, okay? Nothing to see. And if I take this magnet and I put it towards, like on the outside of it, it isn't attracted to this at all because this is a non-ferrous material. But if I take that magnet and I move it close to this stuff, this is what's called magnetron. And when I, if you can see that, as I move the magnet around, it creates a distortion in that film. Okay, it's fairly subtle, but it creates a distortion. So this allows you to see what happens with the magnetic field. So if I take the binder clip and move it, nothing happens because it's not a magnet. But if I take a magnet, okay, oddly enough, you can see a distortion in that. So this is going to allow us to see a magnetic field. So if you look at physics, and there's a lot of stuff that we can see, bowling balls, magnets, that type of thing, visible light, okay? There's a lot of stuff that we can't see either. Okay, so like if you've ever had like a broken bone and you had an X-ray, okay? So there's this whole spectrum of electromagnetic radiation that we can't see, which allows your cell phones to work, okay? Which allows radio waves to be broadcast, which allow microwaves to make popcorn, okay? There's a whole bunch of things that we can't see but yet we know exist. So one of the things that physicists try and do is try and find a way to observe things that we can't normally see. So like, I can't see the magnetic field emanating from the end of this magnet. But if I move it over this paper and then I see a change in the paper, then I go, oh, I can't see the magnetic field, but I can tell that it's creating distortion in the magnet film. Okay, I can see that. So what I'm going to do is I'm going to take this, I'm going to drop it inside the tube. So when I drop it inside the tube, gravity is going to be pointed down. So if I drop it on the outside first, okay, right, it falls like you would expect. But if I drop it on the inside, it takes a lot longer for it to fall. Okay, so do it. I'll even flip it over and just make sure it doesn't, you know, nothing to see. Okay. Oh, all right. So physicists at this point are going, one of two things is either I'm a witch, okay, or we've got to find a way to explain this in terms of forces. So, well, maybe gravity isn't as strong inside the aluminum tube, and that's why it takes longer to fall. Okay, all right. Or we could test that. We take something small and we drop it through there that isn't a magnet, and you see that it falls at the same rate. Okay, so it has to be something to do with the magnet. So clearly, gravity is pulling it down. So there must be something happening inside the tube that creates a force that's opposing gravity. Because as soon as it gets out of the tube, okay, it falls like you would expect. So there has to be something happening inside the tube that's creating the distortion. Now, so we're going to violate the social distancing rules for just a second. So come up here. Come on. We'll do this from the camera. So Jared, here's what I need you to do. Studio audience, this is Jared. Okay? I need you to hold this like this. Okay, got it? Now, what I want you all to watch is what's going to happen in this section right here when I drop the magnet and it goes through. Okay, ready? So here we go. So as that goes through, it's like seeing like a hidden elevator inside of it. So what that's telling us is that as that falls, we can see a disturbance in that magnetic film. So we know that whatever is happening that's creating that opposing force has something to do with a magnet, because notice that there's nothing happening now. So whatever is happening has to be happening because of the fact that that magnet is falling through there. Okay, well done. Thank you. Okay, go back to social distancing. Another thing is that's cool. That's when you get done, is that it's created like this dark band, so it's aligned all those particles as it went through. So what happens, and we'll spend more time talking about this, that's creating what's known as an eddy current. Okay, so the eddy current is basically the aluminum pipe is experiencing the change in the magnetic field. And Mother Nature doesn't like that, so Mother Nature creates its own magnetic field to balance out the magnetic field of the magnet, and that creates a force, and that's what slows it down. So that's a classic example of what physicists do. So they're going to sit there and go, okay, right, don't know what's going on, but we're going to try and figure that out. And then you try and make these observations, try and say, okay, I can't see it with my normal eye, but if I wrap that magnafilm around it, then that is something that I can see happening in terms of creating that disturbance as it falls through. So if you look at like physicists right now, one of the kind of embarrassing things right now is that we're missing a large amount of matter in our solar system and our universe. It's called dark matter and dark energy. So we know it's there. Okay, it actually makes up a large portion of our universe, but we don't know where it is. Okay, and we don't know how to detect it, but we know that it's there. So that's kind of an embarrassing aspect of physics right now. But what we're trying to figure out is like, okay, we know it's there. How do we find a way to detect it? So that's somewhat similar to when I take this magnet and I drop it through. I know that it's there. I know there's an opposing force based upon the observation, but clearly, I don't know how we can observe it. But that's the beauty of that magnetic field. So basically, what physicists are trying to do is come up with a way to find the analogy of magnafilm with dark energy. So if y'all want to win the Nobel Prize in physics, find the equivalent of magnafilm so that you can detect dark matter and see what that can do. Okay, so let's stop for another second, take a break, and then we're going to be on to the home stretch. So we'll pause this again. Okay. All right. So here's one of the most important things that I have to stress to all of you. Like I said, literally, it was almost 30 years today when I taught my first class. And so a little background on me is that after I graduated from K-State in May of 1990, I joined the Peace Corps and I went to the Southern African country of Botswana, where I taught there for 2.5 years. So my first 2.5 years of teaching was in Africa. And then I got hired here in the fall of '93, and I've taught here ever since. So this is like 27 years of teaching here in the Nice District. And I've taught some phenomenal kids, and that's what allowed that solar project to be so successful, is because of the caliber of kids that I teach. But this is very much such a unique and dynamic teaching environment. So there's a couple of things that I really have to stress. One is that if you're not feeling well, don't fall on the sword and go, oh, I'm still going to go to school. Even though I've got a temperature of 101, oh, I'll take some ibuprofen and that'll temporarily knock down my fever. Don't, okay? Especially for this class. This is why God made technology, so that you can be home, you can watch that YouTube video every that day, whatever that is, okay? So I beg of you, do not feel a moral obligation to come to this class if you're sick, okay? Because like I said, I'd like to think I'm young and, I'm 24 years old and I'm invincible, and the reality of it is that I'm not. So there's that aspect. The other thing that's important is just kind of a communication thing. Whether it's the quality of the video. So like, if you're watching the Zoom meeting and I'm out of focus or the camera is shifted, okay, because eventually, you know, like you're going to be sitting over here. So if that's what's happening on those days that you all are remote, fire it in. Say, you know, on the chat deal or Zoom, and go, hey, Burkamp, you know, can't see you, you're out of focus, you know, whatever that is, okay? In terms of pacing, and I did this in the last 9 weeks when you all were remote, and I might do this again. So sometimes what I might do is give you all the answer key. So I might give an assignment and go, okay, hey, here's the deal. Maybe we go completely remote, things happen. So sometimes what I might do is give you the answer key. That doesn't mean that you're not going to be responsible for that material. And some people would like that, okay? Because they like knowing if they have it right or wrong, because they have the answer to it. Not going to happen very often. But what will happen, and this is why it's important that you kind of have the homework done before you come into class. So what I'll typically do is I'll say, okay, hey, here's number 5, okay? And somebody will say, hey, you know, how do you do number 5? And I'll work it out, or at least kind of a broad idea of how the problem works. And then I might go to Lily and go, okay, Lily wants number 5, and I'll say, the answer to number 5 is between like 40 and 45. So I won't necessarily give Lily the exact answer, but I'll give her and say, okay, this is about where the answer should be. So that's why it's important that you kind of have that homework done before you come into class. And I know you all will be busy. I know this is such a really jacked up time. Ideally, I would like that assignment that day, just so I can get it graded and get back to you, because that's one of the things that I spend a tremendous amount of time doing, is grading your assignments. Okay, I spend a lot of time going through those. But if something happens, you're sick, you have a choir concert or a sporting event, you have to work late, whatever. If every once in a while you come to me and you say, hey, Burkamp, you know, hey, can I have an extra day? I'll grant you that, okay? Because I know life gets in the way. Just don't let it become a regular occurrence, because then you get behind, I get behind, and then it just turns into a train wreck. So eventually what you're going to need here within the first couple of weeks, and this is on that sheet, you're going to need a protractor and a ruler. The other option that you can do, you don't have to make this decision now, is you can take this class for dual credit through WSU Tech. It's 5 hours of credit. We'll talk more about that later. So that might be something that you begin to think about. But other than that, we made it through the first day. And anybody have any questions right now? Going once, going twice? Okay, so we'll shut down the meeting, and I will see you all on Thursday. I'm going to email you a link for that YouTube video on the MKS system that you all need to watch. I'm going to try and get that done after school today and get that sent out, and you all have the lecture notes. Okay? All right, break. See you, Kanani.